Hi, this is Dr. Shahriar Hussain again. Today we will be discussing how we can visualize data points and clusters formed by those data points. The library we are going to use is called Matplotlib. We are going to import the PyPlot facilities of Matplotlib as PLT. PyPlot, that is, this PLT, will help us plot the data points. We will create our data in a NumPy array named data. We are bringing in the data from the previous video. In our data, we have 10 rows or objects and 3 columns or features or attributes. We want to visualize each row of the data in a 3D space. Also, we want to separate clusters by using colors. To get the entire column 0 of the variable data, we can write data and in square brackets we can provide colon, comma, 0. This will get the entire column in a one-dimensional array. The colon symbol here means all. In this context, all rows in column 0 will be selected. That is, we provide the column index after this colon and this comma to retrieve a column. To retrieve everything of column 1, we use data and in square brackets we provide colon, comma, 1. Again, the colon symbol stands for all rows and 1 stands for column index 1. PLT has a scatter function to draw scatter plots. We can draw two features or columns using a 2D scatter plot. Let us say we can put column 0 in the x-axis and column 1 in the vertical axis. All we have to do is write plt.scatter and within start and end parentheses provide column 0 of data and column 1 of data. A nice 2D plot is drawn. That is excellent. Let us try to provide all 3 features or 3 columns. We provide all 3 columns 0, 1 and 2. Not nicely done. We expected a 3-dimensional scatter plot, but we have a 2-dimensional plot here. The 3D plot, as we expected, is not drawn. Actually, we need to do something different for a 3-dimensional visualization. We have to create a subplot where we will use a 3D projection. To do that, from PLT, we need to retrieve a figure object and then work on that figure object. We keep the reference to the figure object in a variable named fig. Notice that a figure reference with a resolution is printed. The output is not important yet because we haven't yet provided data to this figure. With the figure, we add a subplot using the add_subplot function. The first parameter of the add_subplot function states how many subplots the figure would contain and in which cell we will place our subplot. 1, 1, 1 here indicates in the subplot grid there should be 1 row, 1 column, and the plot under consideration should be placed in cell 1. In a figure, subplot numbering starts from 1, which is in the top left corner of the figure. In our case, we only have 1 cell since our first 2 digits are 1 and 1. Therefore, we will keep our plot in that only 1 cell which has an identity of 1, which is reflected by the third digit. If we have 1, 3, 1, that would mean the figure has space for 3 plots in 1 row, and the current plot should be placed in cell 1. If we have 1, 2, 1, that would mean the figure has space for 2 plots in 1 row, and the current plot should be placed in cell 1. Our second parameter is what kind of projection the subplot should use. Obviously, we want a 3D projection. We keep the subplot reference in a variable named AX. AX is the plot where we draw our scatter plot. This part draws our plot. The plot is in a figure, which is referred by the fig object. On Google Colab, I just type fig and then press Shift plus Enter. We see the figure. The figure looks 3D, which is what we wanted. However, this is an image. I cannot interact with it. I cannot rotate it and view from different angles. I want to rotate it and see the figure in a 3D space. I want something like this. We cannot accomplish such a visualization easily using Google Colab. To accomplish that, we need to use regular Python on a computer. Now I will take this code to my laptop. I am downloading the Python file. I will do the rest of the work on my computer. Any text editor is fine. I am using Spyder on my computer. You could use PyCharm, you could use Xcode or Sublime Editor, or even just Notepad-like text editors would be fine. The main thing is you need to make sure that you have Python installed on your computer. Also make sure that you have Matplotlib and NumPy installed. I opened the downloaded file on the Spyder editor. I will erase this part. This part was added by Google Colab. Let us run the code that I saved in a file named plot_test.py. Let us run the file using Python on my computer. Since my computer has multiple versions of Python, I use the command python3 to run a Python program using version 3. On your computer, if you have only one version of Python, the command is likely to be just Python. I run the code using the command python and then the Python file name in which my code is written. Nothing was displayed. That is because I have to make a minor modification to the code to get a beautiful interactive display. We will discuss the rest of the code in the next video of this workshop series. Stay tuned for the next part.